Our project is titled How Belief in Ghosts and Other Extraneous Opinions Relate to Political Affiliation and is presented by Cassie Noble and myself, David Kelly. Each year, the well-known card game Cards Against Humanity collects a poll of the American people's social and political views, presidential approval, as well as some other seemingly extraneous information that may or may not have correlation with their political views. We are attempting to use the answers to some of these questions to train an SVM to predict the political affiliation of those surveyed. In the data set that we used, the responses of 1,000 people were collected. Only 482 of these people identified as either Democrat or Republican. This was something I found kind of surprising, that most of the people either identified as independent or don't know. So we only had the 482 entries to work with after performing some data cleaning. In addition to that, we removed all other political and social questions aside from party affiliation so that we could use only the ridiculous questions to classify the subjects. This left us with 12 total questions for classification, and they were posed as a mix of numerical and categorical questions, with the categorical questions consisting of anywhere between 2 and 6 possible responses. The survey questions were the following. What would you say is the likelihood that your current job will be entirely performed by robots or computers within the next decade? Do you believe that climate change is real and caused by people, real but not caused by people, or not real at all? How many Transformers movies have you seen? Do you agree or disagree with the following statement? Scientists are generally honest and are serving the public good. Do you agree or disagree with the following statement? Vaccines are safe and protect children from disease. How many books, if any, have you read in the past year? Do you believe in ghosts? What percentage of the federal budget would you estimate is spent on scientific research? Is federal funding of scientific research too high, too low, or about right? This next one was a little scary. True or false, the Earth is always farther away from the sun in the winter than in the summer. If you had to choose, would you rather be smart and sad or dumb and happy? And the results of this last one were kind of entertaining. Do you think it is acceptable or unacceptable to urinate in the shower? We utilized a 2-class support vector machine to classify subjects as either Republican or Democrat. Our reasons for using an SVM were threefold. First of all, your basic SVM is meant for 2-class classification problems. Secondly, there's usually some sort of kernel function or feature space transformation that you can use to obtain relatively decent accuracy with an SVM, or at least better than random. And finally, the computational complexity of the SVM is relatively low compared to more advanced classification methods such as most neural nets, I guess. We tested various kernel functions, including a linear kernel function, a radial basis function, or RBF, and then several different degree polynomial kernel functions, second and third order. For our categorical variables, we used a one-hot or one of k coding approach to divide, essentially for each category, to divide each response into binary variables so that each response took on a value of either 1 or 0, and only one response to that category could evaluate to 1 for any single subject's response. This is essentially used to take those string responses and convert them to a data format that we can work with. We utilize tenfold cross-validation to compare the relative accuracies, prediction accuracies, I guess, of the different kernel functions. So for our experiments, we were attempting to train a binary classifier SVM to predict political affiliation with better than random accuracy based on the questions from the survey. We were also experimenting with various kernel functions to attempt to optimize the accuracy for the SVM. We also sought to identify some of these outrageous questions that were strongly correlated with a subject's political affiliation. And sort of along those lines, we were also just looking for trends in the subject's responses. So pretty much regardless of how many times we ran our script, we achieved the best average train and test accuracy, both with the radial basis function. So here I have some of the accuracy statistics for one of our tenfold validation runs. So you can see we were getting, roughly in the 70s for both train and test accuracy, and the training accuracy was usually a little higher. Although I was a little surprised that our maximum accuracy was as high as it was on a test set at 83%. I really didn't think that you would be able to predict people's political affiliation that accurately based on how outrageous some of these questions were. As far as the radial basis function performing better than the other kernel functions, we also weren't very surprised with that because it's a pretty common choice for your feature space transformation, and it generally performs pretty well. Had the data initially been linearly separable or very close to it before any sort of transformation, I would have expected linear to perform better, but this kind of indicates that probably wasn't the case. And that's really not that surprising, kind of based on the nature of these questions and the fact that this is a survey. Even though some of these questions are pretty out there, people don't always take surveys very seriously and kind of skew the results and make it definitely hard to linearly separate that data. Cassie is going to cover some of our more interesting results.
So I am going to continue with the results, and here we have a table of the correctly and incorrectly predicted responses along with their actual political affiliation. So you can see in the first column is what the classifier predicted, and then we have their actual political affiliation. And so here we have predicted Democrat with an actual Democrat, predicted Republican, actual Republican. So those are the ones that were predicted correctly, and then these mismatching colors here in the middle were the ones that it did not predict correctly. So these are summaries for those groups, and so for the numerical responses, that's the median, and for the categorical ones, it's the most common response for that group. So you can kind of think of this being the kind of stereotypical responses for this group, and when we compared these responses, like for the predicted Democrat to true Democrat, this actually also matches exactly with if we just compare that to the full data set, only Democrats. So it was able to correctly predict these ones, most likely because they're the easiest ones to detect. Same with the Republican. This is the kind of stereotypical response that we had in the data set for Republican as well. So that's kind of interesting. Those may be the easier ones to detect, whereas some of the responses in these ones are maybe a bit more unusual. Like, for example, this one here was this category was misclassified, and their most common response was that they believe in ghosts, which was not a common response among either Democrats or Republicans. So it could just be that that's a bit more unusual and makes it more difficult to predict that case. So here we have a table of the most extreme and least extremely predicted responses. And so this is not a table of summaries, this is actually for individuals this time. So we have the individual it was most certain was a Republican, and that was turned out to be true. And then the individual it was most certain was a Democrat, also turned out to be true. It was pretty accurate on the ones that it was pretty sure about in its predictions. And then in the middle here we have the two responses it was least certain about. And then in the case of the one that it was least certain was a Democrat, it was actually incorrect about that one. So these are kind of interesting just to compare what it thought was certainly on one extreme or the other compared to the ones in the middle. So could be kind of interesting to see, to look further into, like, maybe are these less extreme in their political affiliations if they're less extremely predicted to be at one end or the other in terms of their political affiliations by this model. Could be interesting to look into. I don't have time to go into all the different results here because there's just a lot. But one thing that I thought was the most interesting in this table was, do you think it's acceptable to urinate in the shower? And only the ones it was most certain about in terms of either being a Republican or Democrat were the ones that said it was acceptable, and then those in the middle said it was not acceptable. So I'm really curious if this pattern holds. I looked at like the top 10 most extremely predicted, and that pattern did seem to hold. So I'm pretty curious about that result. This also may be one of the ways in which these data may not be linearly separable if those in the middle think it's not acceptable and only those on the extremes think it is. So I also threw in this alluvial plot because I just really want to be able to visualize this a bit better. And this actually doesn't include the predictions, this is the actual classes, but I just wanted to get an idea of if there was a relationship between political affiliation and a number of these different variables. The alluvial plot is a nice way to visualize high-dimensional categorical data, and it wasn't supported in MATLAB, so I ended up making it in R, but it was kind of nice to be able to visualize. So the red is the Republican and blue is Democrat. So you can kind of see that there's definitely some trends in terms of some of these variables, like you might expect in the US, at least on climate change. It looks like the majority of that people believe it's real and caused by people is Democrats. And then you can kind of see also with would you rather be smart and sad or dumb and happy? Again, like smart and sad seems to be filled with a bit more of the Democratic group. So you can kind of look through and determine some patterns like that. So it's just a nice way to visualize that. So all in all, as David went through, we had pretty decent accuracy, especially considering we selected mostly variables that we didn't think on the surface should be super related to our classes. So pretty decent accuracy in terms of that. With using the support vector machine, we ended up having a pretty large number of support vectors. It was half of our training set was flagged as support vectors, and the weight matrix, the weights were all quite similar, with the support vectors weighted only slightly more than the other data points. So I'm not sure that the support vector machine is the best option for this data set. Is kind of what leads me to, that's kind of what that leads me to believe. So it would be really interesting to compare this classification model with some other method, try like a neural network or another method and see and compare results. In terms of future work, like we mentioned, we turned this into a two-class classification problem by clumping anyone together who was strongly Republican, moderately Republican, and so on. And we removed any of those in the middle, like those that said independent. So I think it'd be really interesting to do this as a multi-class classification problem and see if you get different results or what that might turn out like. I'm also curious which of the survey questions were the best predictors, because I imagine some of those were more related to political affiliation than others, so it'd be interesting to explore that in a bit more depth. So here's some of our references, and thanks for watching. Hope you found this entertaining or interesting, and let us know if you have any questions or comments.